In this lesson, we are going to focus on functions. The diagram below shows the graphs of f of x equal to ax squared plus bx plus c and g of x equal to 2x minus 2. The graphs intersect at D with the coordinates -1 and -4. And E, f cuts the x-axis at A and B, the y-axis at Q, and has a turning point at T with the coordinates 0,5 and T. G cuts the y-axis at P. Okay, G cuts the y-axis at P, meaning that the coordinates of P will be 0 and -2. Why? Because the equation of G is given as g of x equal to 2x minus 2, and we know that this 2 is the gradient, or is the slope of G, and then -2 is the y coordinate of the y-intercept. Okay, what else do we have? Okay, so far we only have this, but we also have the x coordinate at the turning point of the quadratic graph, or at the turning point of this parabola. You can either call it a quadratic graph or you can call it a parabola. It's all up to you. We also have a straight line or a linear graph that intersect the parabola at the point D and the point E, meaning that at these 2 points, these two graphs are equal. Okay, let's check. They're saying that given that PQ equal to 4 units, the distance from P to Q is equal to 4 units, show that A equal to 1, B equal to -1, and C equal to -6. Okay, it's fine. At P and at Q, the x coordinate is 0 because it is at the line x equal to 0, or it is at the y-axis. Any x coordinate at the y-axis is equal to 0. So we have the x coordinate at P. We also have the x coordinate at Q, which is 0. So we have the x coordinate, we have the y coordinate at P, but we do not have the y coordinate at Q. So that is what we are going to get, and that y coordinate at Q will then be the value of C. Okay, so this is what we are going to do for 6.1. For question number 6.1, they are saying given that PQ, the distance between P and Q, is 4 units, so I'm going to take the distance and square it to find the corresponding y value at Q. So this is what I'm going to do. I'm going to say we know it's y take away -2. It's y take away -2 all squared equal to the square of 4, which will be 16. So all squared equal to 16. Negative into negative will give us positive. So we'll have okay. Well, let me just write it as y plus 2. This is y plus 2, because negative into negative will give us positive. So this will result to, if we take square root on both sides, we are going to have y plus 2 equal to plus or minus the square root of 16, which will be plus or minus 4. And then let's take 2 across to solve for y. So y will be equal to, it comes as positive, it crosses the equal side, so it will be -2 plus 4, or y will be equal to -2 minus 4. Let's add them. Okay, y will be equal to minus 2 plus 4, which is positive 2. Y will be equal to 2, or y will be equal to minus 2 minus 4, which is minus 6. Y will be equal to minus 6. Okay, let's look at the graph. We can see that at this graph, there is no way the y value can be a positive y, because it's below the x-axis. Any y coordinate below the x-axis, it's less than 0. So we can scrub this one out. We can scrub this one out and only allow y equal to minus 6. And this y is the same as the value of c. So we can say therefore c equal to minus 6. C equal to minus 6. Remember, it's the y coordinated q. It's the y coordinated q. So let's proceed to the next question, which is 6.2. 6.2, they say determine or find out the value of t. We are to find, oh, we are not done. We must, we only found the value of c. Now we must go and find the value of a and b. We are going to find the value of a and b. Okay, what do we have? We have the x coordinate at the turning point, which is 1 over 2. So we are going to use that x coordinate at the turning point. We are going to say f prime of x. The first thing that we are going to do is to find the derivative of the graph and equate the derivative to 0. So f prime of x equal to 0. Now let's find the derivative. F prime of x will be equal to, it will be, we're going to derive ax squared, which will be 2ax, and then also derive bx, which will be b, and then the derivative of a constant is 0. So this will be 2ax plus b, 2ax plus b. Okay, let's just say 2ax plus b. But then from here, we are going to say the derivative when x is equal to 1 over 2 is 0. So that's what we must do. The derivative when x equal to 1 over 2 is 0. Okay, this is what we should have. This is what we should have said. When x equal to 1 over 2 is 0. So we are then going to replace x by 1 over 2. We're going to replace x by 1 over 2. And then we know that this thing is equal to 0. It's equal to 0. So 2a times 1 over 2 will be 2a over 2. And 2 will cancel 2. Then this will result to a plus b. So we are going to have a plus b equal to 0. Then we can take either a or b across. So if we take b across, we are going to have a equal to minus b. We are going to have a equal to minus b. Then we know that if the value of a is 1, then the value of b will be minus 1, because a is equal to minus b. Okay, so I can say let this be my first equation. Let this be my first equation. So what am I going to do next? I have the coordinates of d. I have the coordinates of d, and I also have the coordinates of q. I have the coordinates of d, I have the coordinates of d, of q. I'm going to use them. Or I can use, I know that I have 1 point. I was given 1 point. I was given only 1 point at this graph, which was the coordinate of d. So I know that when y equal to negative 4, when y equal to -4, x is equal to -1. So I'm going to say -4 equal to ax, which is -1, all squared plus bx plus c, which is -6. Okay, so what else am I going to do? Okay, I keep the -4. -4 will be equal to -1 times -1 will give me +1, and +1 multiplied by a will just be a. -1 times positive b will be minus b, or this will be minus b minus 6. Then I take minus b and minus 6 across. So if I take minus b and minus 6 across, this is what I will have. I will have -4 plus 6, -4 plus 6 plus b is equal to a. Okay, let's add the like terms. 6 minus 4 will give us 2. So if we add the like terms, we're going to have 2 plus b equal to a, and this is my second equation. Now I had a equal to minus b. Now I'm having 2 plus b equal to a, meaning that I can connect 2 plus b with minus b, or I can equate them. 2 plus b equals to minus b, because they are both equal to a. So if they are both equal to a, I can say that 2 plus b is equal to minus b. And then I will take positive b across. If I take positive b across, I will have 2 is equal to minus b minus b. And minus b will give me minus 2b. And then because I'm solving for b, I will then divide on both sides by -2. I will divide by on both sides by -2. So this will be 1 is equal to, or this will be equal to -1 equal to b. -1 equal to b. Okay, I can say let this be my third and last equation. Well, to find the value of a, I'm going to say a, I'm either going to substitute 3 in 1 or 3 in 2. It doesn't really matter. So if I say 3 in 1 or 3 in 2, I'm going to have 2 plus, in bracket, no, it must be 2. 2 plus, in bracket, -1 equal to a. And negative times positive will give me negative. So this will be 2 minus 1, and 2 minus 1 is equal to 1. 1 equal to a. Or you can either substitute it in the first equation, where you're going to say a equal to minus b, and you are going to have minus into -1, because b is -1. So this will be minus and minus, and then it will give us positive. So a will be equal to +1. So to wrap it up, we can say therefore a equal to 1, comma b is equal to -1, and c is equal to -6. And then to give the equation, of this graph, of this quadratic graph, in the form y equal to ax squared plus bx plus c, we can say f of x is equal to x squared, minus x minus 6. We are done with question 1, and this was worth 5 marks. Going to the second question, it says determine or find out the value of t. Okay, we have the equation. So this is what I'm going to do. You can either find the axis of symmetry, but you don't have to do that because already the axis of symmetry is given as 1 over 2. And then take the axis of symmetry, plug it into the original equation to find the corresponding y value of the axis of symmetry, which in this case is t, or to find the minimum value of the graph. So going to 6.2, this is what I will do. I can either say or I can either take that 1 over 2 and plug it y c x in the original equation. And where's the original equation? Is this equation that we have just calculated in 6.1. Or I can go straight to it, that t is equal to minus b squared plus 4ac all over 4a. So that's what I can do. T equal to minus b all squared plus 4ac, b all squared plus 4ac all over 4a. That's how we find the maximum or the minimum value in a quadratic graph. Okay, so let me replace. My b is minus 1, so I'm going to replace b by minus 1. So this will be minus 1 in bracket, all squared plus 4ac, and a is positive 1. And the value of c is minus 6 all over 4 times 1. Okay, this should give us the value of t. Okay, let's just quickly do it on a calculator. Let me open the calculator so that we can do it and get done with it. Okay, while still waiting for the calculator to open, let me just leave a space where we're going to put the value of t and proceed to the next question. But t will be minus something because I can see by just looking at the graph that the value of t is a negative, or it's less than 0. Okay, so we are going to say minus into minus 1 all squared plus 4ac, 4ac all over 4a, equal to minus 25 over 4, minus 25 over 4. And that's the value of t. Okay, let's go to the next question, which is 6.3. Okay, let's check out the question. It says find out the coordinates of a and b. The coordinates of a and b, we can see that a and b are the x-intercepts of the quadratic graph. So we have the equation where we see f of x, we replace by 0. We have the equation. Okay, let me just copy the equation, and then we know that when we determine the x-intercept of a quadratic function, we let y be equal to 0, or of any function for that matter, we let y be equal to 0. So this is what I'm going to do. I'm just going to copy this equation, rub off these things, and then equate it to 0, equal to 0. Okay, let me then look for the factors of 6. Then when I add them up, they must give me the middle term. So looking at it, I have x plus 2, I have x plus 2 and x minus 3. Okay, let me look at it before I get carried away. Okay, positive 2 times negative 3 will give me minus 6. 2 minus 3 will give me minus 1. Okay, we are on the right track. We are on the right track. So I can simply go straight to the answer. X equal to negative 2, or x is equal to positive 3. So the coordinates of A, in this case, the coordinates of A will be minus 2 and 0, minus 2 and 0, and then the coordinates of B, let me just say B will be equal to, the coordinates of B will be equal to 3 and 0. We are done with this question. So let's go to the next question. Let's go to the next question, 6.4. Okay, what are we told? Determine the coordinates of E, the other point of intersection of F and G. Okay, we have the equation of F, we have the equation of G, and the equation of F and G are equal at point D and point E. So now what we are going to do is to find the coordinates of E. How do we find the coordinates of E? We are going to equate the equation of F and the equation of G, then solve for X. Then after we find the X value, we are going to substitute that X value either in the equation of F or in the equation of G, because at these 2 points, they are equal. Okay. So this is what we are going to do. We are going to take this equation and equate it with 2x minus 2. So it will be equal to 2x minus 2. Then from here, I'm going to group the like terms. I'm going to group the like terms. So I'm going to have x squared. Okay, this is what I'm going to have. X squared minus x minus 2x minus 6 plus 2 equal to 0. Okay, let's add them. So we have x squared minus 1 minus 2 will give us minus 3x. Minus 6 plus 2 will give us minus 4, if I'm not mistaken, equal to 0. Okay, let's just confirm it. So we are on the right track. Minus 6 plus 2. Okay. We can factorize this trinomial. So let's try to factorize it. The factors of x and of x squared is x and x. So I'm going to have x minus something, either minus 4, okay, x minus 4 into x plus 1. These are my factors. And I remember I have to have x plus 1 as one of my factors, because at D I already have the x coordinate. I already have the x coordinate, which is minus 1. So if I have x plus 1, then I know that when I'm going to solve for x, the x value will be equal to -1. So it's very much correct. It's very much correct. So let's just without wasting time, solve for x. So x will be equal to 4, or x will be equal to -1. And then we know that this value of x is not the x coordinate. It's not the x coordinate at the point E. So we are not going to consider it. Let's only consider x equal to 4. So to find the y value, we can substitute x equal to 4 in the equation 2 into x, 2x minus 2. 2 times 4 will give us positive 8. So we are going to have positive 8 minus 2. And 8 minus 2 will give us positive 6. So the y value is 6. Okay, let me just show that we are determining the y value. Okay, the y value is positive 6. y equal to positive 6. So the coordinates of E will be equal to, is it positive 4? Okay, let me first show that I'm determining the coordinates of E. The coordinates of E will be equal to 4 and 6. 4 and 6. Okay, let's look at the diagram itself. We can see that it makes sense, because both y and x at E, they are above the x-axis. And it is where y is positive and where x is positive. They are in the first quadrant. Okay, we are done with 6.4. Now they are saying write down the range of f. Okay, the range of f starts from the minimum value going up. So it's from minus 25/4 to positive infinity. Or you can see that the range is greater or equal to. This is what we can say, that on 6.5, the range y is greater or equal to minus 25/4. And you are done. You collect your self marks with these easy steps. Follow for more.